find n so that Rn is less than or equal to 1000 for some n equals 1 to infinity of e to the minus n halves. So, as we know, Rn is greater than or equal to 0, less than or equal to the integral from n to infinity, f of x dx. So let's start off by computing that. So we have to take a look at the limit as b goes to infinity, and here in this case n is unknown, so it's going to be the integral from n to b, and f of x is e to the minus x halves dx. So integrating, we get limit as b goes to infinity, e to the minus x halves times negative 2, evaluated from n to b. And so that gives us minus 2 on the outside limit. B goes to infinity of e to the minus b halves minus e to the minus n halves. And we want this to be, if this is less than 0.001, then Rn will surely be less than 0.001. So we want to set this less than or equal to 0.001. Now, when we compute this, b goes to infinity, this is going to go to 0, and here we're going to get minus 2 times minus, which is positive 2e to the minus n over 2. So we need to solve. 2e to the minus n over 2 less than or equal to 0.001. And so we divide by 2, take the natural log, we get minus n over 2 less than or equal to, take half of this and we get 0.0005, and we got rid of the e, so we have to have a natural log here, and multiply by negative 2, and n has to be greater than or equal to negative 2 ln 0.0005. And so we get the decimal approximation here, and n has to be greater than or equal to 15.2, so therefore n has to be greater than or equal to 16. So if we have 16 terms in our sum here, so e to the minus 1 half, e to the minus 2 halves, e to the minus 3 halves, all the way up, and we add through e to the minus 16 halves, then that will guarantee that when we add all that up, that estimation for S16 will have an error of less than 1/1000th.